Hello students, again welcome to online classes. We are to start relation and function, class 11, module 7. In this module, today we will study domain. Only domain are functions. So firstly let us start. A is any set which contain 3 elements and B is any set which contain 2 elements. This is A and this is B. Then Cartesian product A cross B is written as 1 4, 1 5, 2 4, 2 5, 3 4, 3 5. This is called Cartesian product. Now what are the relations? Relation may be empty set. Relation may contain only one element from Cartesian product. Relation may have 2 elements, 1 4, 2 4. It may have 3 elements, 1 4, 2 4, 3 4, like this. Or relation may have all the elements. Because relations, they are subsets of A cross B. So if we talk about this relation, in this relation, domain is empty set which contains no element. Domain. For this relation, domain is only first element and that is 1. For this relation, domain is, what is domain? 1 2. And for this relation, what is domain? It is 1 2 3. So for every relation, there are different domains. Sometimes empty set, sometimes 1 element, sometimes 2 elements, sometimes 3 elements. But when it is function, when we talk about function, in function, this set is called domain. What is domain? For function, domain is A, full set. Let f is a function, f is a function from x to y. Let f from x to y is function. If we say it is function, then domain is, what is domain here? S. So for function chapter, domain is fixed. Domain is this set and this set is called codomain. But relation, every relation has different domain. So let us take some functions and find out its domain. In this module, we are to find out domain of different functions. Suppose function is fx equal to x minus 1, x plus 1. Suppose it is first part, x minus 1, x plus 1. Suppose second part, fx is x upon x minus 1, x plus 2. Suppose function is x upon x square minus 1 and suppose function is simply x square plus 3. Now these are the functions and we are to find out domain. We are to find out domain. So when we are to find out domain, first thing what we have to keep in our mind, denominator should not be equal to 0. No matter that is 0, because 0 by something is 0, but something by 0 not possible. So we are to see denominator, not the numerator. So when this is the function, we are to find out domain. First thing we are to keep in our mind, x plus 1 should not be equal to 0. Denominator should not be equal to 0 and therefore x should not be equal to minus 1. This number, domain, should not be equal to minus 1. Now what is domain? Domain is this one. See this. This is x-axis, this is y-axis. This is called domain. X-axis and this is range. Now what is here? X should not be equal to minus 1. X not equal to minus 1. It means, what is domain? Domain is all real numbers except minus 1. For this question, domain is all real numbers except -1. What is this R? This R is this x-axis, and it is called y-axis. When we talk about domain, we talk about x-axis. All real numbers except -1. Again, see the question. That question is this, and we have to find out domain. So numerator may be any number, but denominator should not be equal to 0. It means x minus 1, x plus 2, this term should not be equal to 0. And therefore, x minus 1 should not be equal to 0 and x plus 2 should not be equal to 0. This number should not be equal to 0, this number should not be equal to 0. Both should not be added, and means both. And therefore, x should not be equal to 1 and x should not be equal to -2. X should not be equal to 1, x should not be equal to -2. So these two numbers are not possible. And therefore, what is domain? Domain is all numbers except, you have to leave 1 and -2. Make a set. In set, you have to write down two numbers. Subtract these two numbers. You have to exempt 1 and -2. Leave these two numbers. Remaining part is domain. Again, see. For this question, x square minus 1 should not be equal to 0. X square should not be equal to 1. X should not be equal to +1 and -1. And therefore, domain is all numbers except 1 and -1. Except these two numbers, all are domain. So again, this question. For this question, what is in the denominator? In denominator it is 1. And 1 never be equal to 0. So what is domain here? Domain is R. First thing we have to keep in our mind, denominator should not be equal to 0. This value not equal to 0. This value not equal to 0. This value not equal to 0. Find out value of x. X should not be equal to +1 -1. From R, you have to subtract, you have to leave these two numbers, remaining is the domain. Second, suppose question is fx equal to modulus x, absolute function. Fx equal to greatest integer function. Fx equal to absolute x divided by x, modulus x divided by x. Fx equal to x minus 1 divided by x minus 1 modulus. See these questions. This is called modulus function, absolute function, greatest integer function. Sometimes modulus in the numerator, x in the denominator. Modulus in the denominator, this number is in the numerator. And question is find out domain. Now for this question, you have to see the denominator. And denominator is here 1. So what is domain here? R. For this question, again you have to see the denominator. And denominator is 1. Therefore, the domain is R. For this question, x should not be equal to 0. Denominator should not be equal to 0. And therefore, domain is R minus 0. And similarly, for this question, x minus 1 should not be equal to 0. X should not be equal to 1. And therefore, domain is R minus 1. So it may be modulus function, may be integer function, you have to see the denominator. If denominator is 1, it can't be equal to 0. Domain is R. What is the meaning of domain? Domain means value of x. R means if I put 1, if I put 2, if I put 3, if I put 1.1, 1.2, I am getting the answer. So if denominator contain any number, denominator contain any variable, you have to see this value should not be equal to 0. Find the value of x. So r minus this 0, this is domain. Minus means you have to leave this number. You have to leave this number. Except this number, all the numbers they are domain. Next thing. Suppose question is fx equal to 1 upon under root x minus 2 or fx equal to under root x minus 2. It may be x minus 2, it may be 2 minus x. So when question contains root, our second concept is root. Inside root, there should be no negative number. Because when root contains negative number, it will become complex number. So inside root, number should be positive. Number may be 0, 0, 1, 2, 3, positive number. But if it is negative number, it will become complex number. So when root is there for the domain, you have to write down x minus 2 should be positive. This number should be greater than equal to 0. If this root is in the denominator for domain, you have to write down x minus 2 greater than 0. When x minus 2 is in the numerator, it may be 0. But when x minus 2 is in the denominator, it can't be equal to 0. It is greater than 0. When in the denominator, greater than 0. When in the numerator, greater than equal to 0. This number may be 0. But here number should be positive, greater than 0. And from this we get x greater than 2. From this we get x greater than equal to 2. X means domain should be greater than 2. If this is number 9, which contains only x, 2, x should be greater than 2. So what is domain here? Domain is equal to 2 to infinity. Greater than 2 means 2 to infinity. And here x should be greater than equal to. And when equal to, so domain is too close to open infinity. This is called semi-open or semi-closed interval. Always where there is infinity or minus infinity, you have to put open interval. And when equal sign, 2 is closed. When greater than, open. It is 2 to infinity. It is too close to infinity. See again, 2 minus x in the numerator. So for domain, 2 minus x should be greater than equal to 0. It means minus x should be greater than equal to minus 2. And when in equation, we cancel certain minus, sign will change. Inequality sign change. So x should be less than equal to 2. And when x is less than equal to 2, therefore domain is minus infinity to 2 close. Less. Number should be less than 2. Less than equal to 2. Less. And small number is minus infinity. Start from minus infinity. Minus infinity to 2. Whenever there is infinity or minus infinity, you have to put open interval. And when here it is equal sign, 2 close. So whenever the question contains root, you have to keep in your mind that this value should be greater than 0. This value should be greater than equal to 0. This value should be greater than 0. And then find the value of x. If question is like this, that question is fx equal to x, 1 minus x, 2 plus x, like this. But what is written here? 1 less than x less than equal to 2, 2 less than equal to 2 less than x less than equal to 7, and here x greater than 7. If question is like this, then this is true. You have to take union of these. What is first part? First part, this is number line 1 to 2. So from 1 to 2, but 1 it is open, for 2 it is closed. 1 to 2. For second, 2 to 7. From 2 open to 7 closed. And then greater than 7. Greater than 7 means x value greater than 7. Towards infinity. And for the domain, we have to find out union of this. This first part, second part, third part. And union of this is from one open to infinity. This is true. Second, if question is fx equal to x square, 3x, 1 minus x, it is 0 less than equal to x less than 3, 3 less than equal to x less than 5, and 5 less than equal to x less than 7. So they are the domain. What is first part? First part is from 0 to 3. 0 close, 3 open. Second part, 3 close, 5 open. And third part, 5 close, 7 open. Now what is domain? Take union of this. 0 to 3, 3 to 5, 5 to 7. But 0 here is closed interval and 7 here is open interval. So domain is 0 close to 7. So whenever function is like this, this is called domain. This is called domain. So this is first model of domain. In next model, we will discuss some different question of domain part. It's okay. That is from my side. Thank you.